All right, hello everyone. So welcome back to the second, uh, I guess, lesson in the workshop series through the IPR work group. Um, so just as a refresher, if you want to access this, and I'll drop the link in the chat to see if anyone would want to copy paste it that way. But if you go to that link that I dropped in the chat, or you just search up our working group GitHub or Buckeye PR, our working group. As a reminder, this is where we get all the information for the course. Additionally, we're going to be working on February 20th, which is today's date, Dplyr and tidyverse and healthcare analysis. Dplyr, tidyverse are two types of packages. I have the slides, files intro, files healthcare. As a reminder, if you click the files and then you navigate and download all these files, you can work on this together. Just as a refresher of the layout, if you do .html, that's going to be the slides today's workshop. If this is the one we're going to be working with today, and then I believe if you go to today's date, which should be on here, if you go to intro dplyr.rmd here on today's date or previous date, honestly, it should be the same. But also the demo two, which is going to be the healthcare analysis, will be there. So I'm gonna close, I guess just to demonstrate it. If you want to download this, it's as simple as opening up the file. You see a bunch of stuff. You see my name. You just hit that download raw file, and you can open it directly by double clicking on it. Okay. Before we jump to the slides, I want to show this wonderful resource called our cloud. So basically, you have the ability to, instead of downloading all that stuff onto your computer, you can simply search up R online or POSIT POSIT cloud. You can create a free account, and then now you can like open up R files. It's a complete R Studio environment. In fact, if you open it up, it's going to look identical to what we have been working with for the past couple hours in the previous session, and then also today. And once it loads, it's a complete R environment. Even this is a workshop, so I do other workshops at Ohio State. It works almost actually it works identical to the one on your computer, except it's online. You don't have to like savings optional, honestly. I even have unsaved changes, and anyways, it's definitely a work in progress. I'm not too sure about some of the errors, but I have found this to be extremely useful because you can share this link to anyone and they can open up directly what you're seeing. So you don't have to share files, it's just a link. All right, enough of that. So just gonna jump back into the RStudio environment just so we get all acquainted with it. Just as a refresher, this is what my window looks like. You can see my top bar. I like to work with some of the stuff here. So for instance, we have code. I like to see this insert chunk. Um, and sometimes re-indent lines. It's just kind of reformatting. You don't worry about that. And then additionally, I like to work with file, new file, and then R markdown. As we talked about, this is the window that opens up for me. Just, change it to however you'd like. And just as a refresher, to open up a file, it's as simple as double clicking it. So I'm working with today's date. I have the GitHub link stored onto my computer. Double click it. It opens directly up. Don't believe me? We can close out of it. Double click, open. Okay. So the next part, what we're going to do is we're kind of just going to navigate. I'm just going to close this. We're going to navigate Dplyr. So DPLYR, I call it Dplyr. It's really an important part of how you manipulate data, clean data in R. Dplyr is part of a larger package, which I alluded to earlier, called tidyverse. So tidyverse is a collection of, I want to say 6 packages, so ggplot2, 4, et cetera, et cetera. To be honest, I've worked a lot with tidyr. I've worked a lot with Tibble and ggplot. Forcats, string R per. Not too familiar with, at least just at the package name level. I'm sure I've used a command here and there. So just a refresher, this code is here. So the best way to kind of understand this is by, I'm going through the slides, just try to find that line of code here. I know I've like removed some stuff here and there. Do your best to try to follow along. You can hit this green arrow right here to run it. And if you don't have any errors, should be okay. If you didn't have a package installed, there should be a bar up here that says, please install this package. And I've left some text here that you can read. Everything here is on the slides. Just keep going, and I want you to understand what you're doing. So for instance, this is install.packages Dplyr. It installs the package, and then now you can load it with a library command. To note, you don't have to do it this way. As I talked about last time, which unfortunately for fidelity's purposes was not recorded, you don't need to do this install of packages. You can simply navigate to packages, hit install, just type in the package you want. If you want to download my package, it's called CLIOT. If you want to install it, go ahead. It's installed. And you can additionally load a package from this menu. So let's just say you want to load the package I use, just hit that. And I'm going to unload it by doing this. Moving back to this. So as I mentioned, installing, loading. And Dr. Thomas called this grammar. I like to call this just commands or data structures. So we mentioned rows and columns, and we mentioned those go into something called a data frame. Dplyr enhances what we think about commands. So I've told you you can assign stuff by doing the greater inequality sign line. So you can assign stuff to variables, but we can learn a new type of command, which is this pipe operator, percent, the inequality sign percent, specifically this. I work a lot with filter and arrange. So filter is filtering your data frame based upon a pre-specified thing. So unfortunately, I can't show you my code that I work with the NIH, but I can show you this. So typically, you're gonna have a data frame name. So we're gonna hold this data frame. Just example. I'm writing it here. Remember, if it's not grayed out, it's not a command. Data frame filter. So as right now, if you just do this, nothing will happen. You're not telling it what to filter by. But let's just say we're working with patients, and we want to say age is equal to 2, 1. So importantly, I don't put 1 equals. So an important part about programming is learning logic. And logic, if you don't take away anything from this, just remember one thing. Don't put 1 equals, put 2 equals. That's all you need to remember. So this says make age 1, the variable age 1, and then filter that. That makes no sense. Like, you're gonna get a bunch of errors and be like, hey, what do you mean assign age to 1? You're telling me to filter a whole data frame or like basically the Excel in R, but you just set a criteria. So conditional criteria, 2 equal signs. So now it says filter if only if a patient's age is 1. Similarly, you can put that and say only the age is bigger than 1, less than 1, greater than or equal to, less than or equal to. Additionally, you could say age not equal to 1. And you can even provide it logic. So you can say divided by age. So now we're saying filter only if an age is not equal to basically the reciprocal of age, which is a really complicated thing that I don't want to think about. So that's filter. The next command is slice. I will not introduce because frankly, I've not used slice in my practice. Arrange is a really important thing. So let's just say I want to arrange. So arranging a data frame. So note how I'm, if I type this right, aligning this. So data frame that we have, no, we can be called anything. Let's just say we call it patient data or just patient data. Pipe operator, arrange. So now let's just, we have a data frame or a patient data set, and it's a lot. It's like patients are kind of in there at random. So every row is a different patient, but the patients are not organized by age. When you're reading it top to bottom, it's not uh, listed by age. So you'd say arrange by, and just type the variable you want, age. It could be arrange by name. So arrange probably alphabetical to my understanding. Or arrange by nothing because you want to fill that out later. And you can say filter by age is bigger than 10. So you can say arrange by age, blah, blah, blah. And you can change the order, but remember the logic. So you're filtering, then arranging, or you're arranging, then filtering. In this case, it wouldn't particularly matter, but keep in the back of your head. And then summarize. So summarize is another very, very useful thing. So before I get too ahead of myself, I just showed you stuff that I do. Let's go back to the slide. So follow along with your code. Summarize basically is you group things by a variable. So group by a group. So let's just say you have 2 patients, group A, group B, and let's say you want to figure out the mean of group A's age. You would do summarize, and then you'd put something in there. Select is also really important. So select says select a column. or select a variable in my data frame. Rename is rename that variable. And mutate is probably the most important thing I've ever done. Mutate is how you modify columns. To modify rows is a little more challenging, but to modify columns, you use mutate, which says, for instance, you could like change the age, make all the ages plus 10, or make it in days, so times 365. So try to follow along with the code. And just as a refresher, green, hit that. Oh, and let's just say I ran this code earlier. Let's just say you don't want to see this anymore. Hit the settings icon, hit clear all output, and then it'll delete it. And you can run it again. All right, so when you run this, remember names is looking at the column name, or sorry, the just like the column names of the data frame. So in this case, we have around 11 columns that focus around car stuff. So we're gonna take the data frame. So empty cars. So do I have this load cars? I think load cars is in here. Or sorry, cars is already loaded. My bad. So we're going to take that data frame, empty cars. Remember, you can only do names on a data frame. So data frame, pipe operator, select. So select is select the variable columns, MPG cylinder. So if you have two things, put a comma, nothing else. Just simple as putting the names. Another pipe operator, this. Dr. Thomas put in three separate lines. I like to put them in one line. I don't know if I can show you some of my code. I will do my very best. Um, this is embarrassing because I know it's recorded. All right, so oh, good God. Yeah, so I like to put all my stuff in one row. And you can see I use mutate. I have complex conditional logic. I use something called case when. I'm sure if we keep going in this like very lengthy document, we'll find all the other instances I use. Oh my gosh, yeah, I even do more complex stuff, making something called a regression table or a GT regression table for odds ratios. I'm not gonna get ahead of ourselves here, but yeah. All right. So if you arrange it, so we selected the two columns we wanted, so MPG cylinder, and to note, this column, don't worry about it. That's just it's just like a row identifier. It's specific for this data frame. Typically in real practice, this column would be called names or called patient ID, car ID, but in this case, it's a special data frame that you don't need to do this. It's like a testing one. Just note that this is not normal. And then we would arrange it by miles per gallon. So it'll arrange by ascending, so 10.4 to 15.8, and then descending by the number of cylinders. In this case, they're 8, but I guarantee there's going to be 4. Now let's just say we select the columns we want, but now we want only 6 cylinders. It'll show all the complete data frame. So note the variables we selected only with 6 cylinders. I have never done this in my life. If we have criteria, so like for instance, if we say, why is this? Okay, so let's just say we select the miles per gallon cylinders, and let's say we want more than 4 cylinders. So select rows or cars that have more than 4 cylinders above 22 miles per gallon. It'll show up 0 rows. There's nothing in that data frame that meets that criteria. However, you make it 18, you can see there are stuff. So this is really powerful when you're looking at the data frame. You want to figure out by some conditional logic what you want to do. So you can use this symbol for and. So to note, you can use this is and then this is or. You can do complex stuff like age above 60 and I don't know, ethnicity equals Hispanic. I guess for this purpose, because it's like more of like a longer word, I put quotations around it. You can put one quote, doesn't matter. And then you could say, or, I don't know, age is below 60 and ethnicity equals not Hispanic. So you can use conditional logic, and it's a wonderful mathematical phenomenon course to learn. So note I use and or. Um, Honestly, if you guys want me to go into and ors, I'm happy to do so, but I do believe it's not worth a whole workshop on. Um, I guess I can present conditional logic if I have time and before my next meeting. Um, As I mentioned, due to technical difficulties, I have to do this online in a different environment, but typically we would be in the bottom floor of Townsend. Okay. Slice. Oh, okay. So Slice is printing rows. Never had to do that. Honestly, I've never really had to look row by row, but I suppose that's one way to do it. Because typically what I would do is I would say select blah 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 filter, and I would say filter car equals Mazda RX-4. Like I wouldn't do this per se, but I can understand when this might be useful. It's just whatever your preferences. All right, so let's see. Columns, mutate. So mutate, let's just say we select MPG and cylinder. What we're gonna do is we're gonna make this column called MPG2. So a new column, new variable, and we're gonna say that's gonna be equal to the miles per gallon of the vehicle in question, 21, and divided by 1,000. So it'll become that. And this is important actually. So when we're doing this, we're not actually modifying the data frame. We're just saying, hey, print out whatever happens if you modify it. But we need to save the data frame to your workspace. So what you need to do is you need to assign this operator like we talked about last time and say, make this into a data frame called new empty cars. So you can say new empty cars. Don't even worry about that. This is the same thing as saying percent inequality percent. All right. Um, you can also replace values. I mean, I've never had to use replace per se. I just use mutate, but oh well. I pray Dr. I appropriate these slides from Dr. Thomas with his permission. So now we have summarizing data with Dplyr. So now summarize is with a Z. Remember it's with a Z. There's a package that is called, it's very similar to Dplyr that has summarize with an S. Just mind it. So now we're saying we take this data frame, pipe operator, summarize, and we're saying just produce to me the mean of cylinders for all cars, the standard deviation, blah, 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 blah. And we're saying make, and we're saying, in addition to this, present a column 4 that has standard deviation of the miles per gallon. I'm never going to do quantile. Yeah, so summarizing is important because I told you can summarize by certain groups. We're summarizing by VS, never heard of that, and the cylinder. So by cylinder, what is the mu HP? And it presents that. I've never had an error with this in my life, so I mean, it might be important. All right, so now that we've covered this, I'm gonna shift gears. If you ran it, should be good. If you follow the slides, perfect. So now we're gonna flip over to my demo I have. So remember, if you go to the document, just download it, and I'm gonna take a brief refresher. I'll be back in 1 minute. All right, I'm back. So now we'll be talking about cleaning and analyzing healthcare data. So unfortunately, I don't have nice slides, but what I like to do between switching our documents is I like to hit this broom icon, yeah, remove that kind of stuff. And then I also like to hit under this run thing, just literally hit the run thing, like just hit the tab, it'll open this drop down and just go to restart. And you'll restart the R session. And you should be just like a fresh thing. You don't have to close in and out and whatever. All right. So now that we're working with this, I like to go top to bottom. So this is now all my content. This top part is when you make this a PDF, it'll show up on the top. You can modify this however you'd like. I prefer not to because it's my intellectual content, but you do you. So now we're here. This is basically our import statement. So if we're being super precise, we would put all our little import commands. I have these commands kind of strewn out to show you where things go. But if we're doing a good R document, R markdown document, we would do this, and then we hit run. No errors, no errors. Don't even worry about this stuff. Okay, so well, let's just say in the real world, we don't really have our data in one place. So sometimes we have EMR data, survey data, patient reported data, hand enter data, blah blah blah. And EMR can include like clinical facts, like a diagnosis, length of stay, survey data, social facts. Honestly, there's a whole bunch that exists. You, I see someone joined. So I'm actually recording this. You're welcome to stay. I'm right now in the healthcare analysis 2 portion, and I'll be posting this recording probably to the website. So with the survey data, you can have a lot of different things. Um, now that I get back to what I was doing. Um, Basically, data's messy. And as I mentioned, numbers are stored as text, like 99. Oh, wow. Yeah. And then you can have like 999, which is like the default for, I believe, like red cap or something for missing values, and ID numbers don't always match. So we're going to like simulate some data. So don't even worry about what this is. This is just my thing. And as I mentioned from last time, we would use this read-CSV. Um, so we have this and it produces data. And I use this head command. You don't have to. You can also just do this. You just type the data frame directly and it'll open up in the same similar view. And we can see we have 6 patients, diagnosis codes, which are not real, length of stay, which is frankly realistic. You're gonna have some people put 5 days, numbers, and then unknown, and then you have readmitted as a flag. Characters, as I mentioned, are text, and doubles are numbers. So R is very strict about data types, and for instance, let's calculate the mean of the length of stay, and we're gonna get an error because we have this unknown. 2 ways to fix this. One of them is to simply take this unknown and make it an NA, which is what we're going to try to do. So we need to remove days from the numbers, turn the unknown into NAs, convert the columns to numeric, and then convert that readmitted flag from a 1 to 0, which is currently fine, but we want to make it something called a factor, which is how we can do analysis with it. So um, I don't know where my, oh, here we go. So what we're going to do is we're going to say, take the data frame, and we're going to assign the new modified data frame to something called EMR clean. I like to use this convention with underscores. Some people are the opposite. So pipe operator and mutate. So now we're going to do something. We're going to clean the string text. So this is a new command called str replace. So it takes the string. So in the case of length of stay, anything here that has days. So we're going to say if it contains, I apologize. If it has space, days, space, days, like the other one, remove it. We're take so this is what we want to find, and this is what we replace it with. If you put 2 quotes with nothing inside, it basically removes it. If you put a space, it'll just replace the space days with the space we don't want. And then we're gonna say we're gonna assign. So what we do str replace. This is this saying with that column, we're gonna remove all the days, and we're gonna assign that to a new column called length stay clean. And we're gonna say with a length stay clean, we're gonna say if there's an unknown in that new column, which remember there's an unknown in that original column, make it an NA. So it'll turn the unknown to an NA. That's step one. So we are removing days, making it NA. And then what we're also going to do is we're going to say, take that clean column and we're going to say, make everything numeric. I know you saw double. You could also do as double, but typically as numeric is standard practice. And that's how you make this length stay numeric. They're all numbers now. So remember, we took this column with days, unknowns, missing value, weird stuff, and we made it numeric, which means we can calculate that mean later. And then for readmission status, you can leave it as a double, but this is like the data type. So it's like currently it's numeric. So we're saying one is like 100. Remember, this is categorical if they're readmitted. So we have to convert it to a factor, which is a categorical variable. So we're saying factor parentheses, assign whatever that is to the readmission status, take that readmitted flag, and we're saying there's two levels, 0 and 1. 0 is no readmission, 1 is readmitted. Try to follow the same syntax, and honestly, I don't remember this, so sometimes I just copy paste between documents. And then this glimpse is one way you can see the data types. Frankly, again, you could just do this, and it'll still show you double character, double factor, which is awesome. We did it. So now we're moving forward a little bit, and now we're going to try merging data sources. And we're going to use probably the most essential command that I've had to do working with really messy data called left join. There's something called right join, outer join, inner join, and then merge. But we're going to focus on left join. So in the income column, wait, there is no income column. Unless I did something wrong. Oh, unless I Oh, yeah, there's a new data from survey raw. I guess I'm gonna put that here for our purposes. If you remember, just put the data frame. I didn't even realize I made this by accident. Okay, so survey raw. So we're gonna take that raw survey data. So just for our purposes, make a new chunk, Command Option I for me, put that there so we can see it. We are going to handle that 999 in this column, and we're going to make it NA, which is what this does. So we're saying if else. Again, the logic behind it might be above my pay grade and above what we're trying to accomplish. We're not trying to become master programmers here. We're just trying to analyze the data that we're given. We're trying to keep it internal. We don't have to pay someone else to do this per se. But if else basically says if this, make it this, essentially. And then it says if else, so like if 999, make it NA, but if it's not, just put what was already there. Run it. That's what happens here. We assign it to survey clean. And then now we're saying take that EMR clean, left join. So we're going to take that tire data frame on the left, and then we're going to take that survey clean we just made on the right, and we're going to match it by patient ID. So what happens is the similar column is matched. So every patient one has the variables that are so actually I'll show you what it looks like raw. It has all the variables of both data frames combined with no repeats, essentially. If you had more repeats, you would say by equals, and you would put all the repeated columns. And then I just selected the columns of interest. I'm going to take a brief breather. Give me 1 minute. All right, back. So now we're going to focus on analyzing the social determinants of health from that survey data as well, just the combined data. So we're going to use something called a contingency table, which you can just reference by table. So you can run this entire chunk. I mean, I'll do that for us, but I'll talk about it now. So table literally just makes the table. So it takes this as our we'll call it like what do you call this? Like the vertical column, x-axis. This would be your y-axis or horizontal column. So basically we're saying just compare the two, just see where they overlap. So for stable housing, no readmission, two readmitted. Unstable housing, no readmission, zero readmitted. And this is a ggplot. So now ggplot honestly is a whole separate ball game. I don't really want to spend too much time in it because we have more important stuff to talk about. But basically, I would copy paste this and I want you to understand it. ggplot, this is your data frame. Don't worry about AS, it's just aesthetics. X-axis, and we're going to color them by the y-axis of our table, the read mission status. So this is all read mission status and makes a little legend there. Don't even worry about this. Labels, title, y-axis, x-axis, and again, this has to match this. Not by name, but just like what you're talking about, because this is going to go here as your legend. And then, I mean, I don't really change anything else, but you can make like theme. I think you could do theme black and white, if I remember correctly. Um, yeah, doesn't do much. All right. Yeah, you can Google this though. There's more and more out there. So now we're gonna do some statistics. I don't know what's actually gonna happen. I think I wrote this earlier, but oh, there we go. So yeah, it's non-significant chi-squared. So we're comparing we're basically making that table just comparing between groups, and we can see that we have 1 degree of free blah blah blah. But yeah, we can do stats, chi-squared. We can just do correlations, et cetera, et cetera, et cetera. Beyond the scope of this and beyond what I ever do in my own practice. So I wrote some takeaways here. So we're gonna import some new packages and we are going to do some stats. So we're gonna simulate some data. Don't even worry about what this command does. I've commented it for your own pleasure. And again, you don't have to use head. You can just literally just do this. So head just produces the first 6 rows. I want to see the entire data frame, and you can scroll through it if you really want. And you can hit this icon to make it bigger. Okay. So So in healthcare, we really care about date values and subtracting like how we read dates, year, month, day, month, year. It'll fail if they're text strings. So this command makes them all dates. So YMD is our variable. So it basically says YMD. We take that date, make it we take the textual date, assign it to a new column called date. Remember, it's all within the Dplyr commands, and it's within a mutate. So mutate's how we modify columns, and we're modifying a column. And now we're going to say discharge date minus admit date, and we're going to say whatever this number is, I don't want it to be a character. I don't want it to be a string. I don't want it to be anything else except a numerical variable. And we can see here. I'm kind of glossing over this, more so because we're almost at that hour mark or 45-minute mark. And also because a lot of this is I commented okay. And now what we're gonna do is we're gonna take uh the data in our new data frame and we're gonna visualize it to look at specifically non-normal data and we're gonna work with log transforming. So we can see this is clearly a negatively skewed data frame. Um, sorry, I apologize, positive skewed maybe. And this is the mean, the median. So clearly we might need to adjust by the median as opposed to the mean in this case. So I even talk about what happens next. No. But that's how you visualize data. So just keep in mind, same ggplot. I kind of remove the stuff that we don't need, but yeah. Um, so zip codes typically are numbers. Zip codes are something we work with a lot, and they're meaningless mathematically. They'll treat them more as a categorical variable. So as specifically as a factor. So treat as a category, not numeric, is basically this. This tidy, honestly, is so if you just do so let's just say we don't do tidy. Let's just say we just do good model, which is I'll talk about that in a sec. It'll show you this. I work with this view a lot. So it tells you the coefficients, tells you the AIC for social deviance, but it doesn't tell you the R value in this case, or it tells you other things, or the odds ratio. But if you do this view, it'll tell you the p values, it'll tell you the estimates, standard errors, etc. And that's how we interpret models. So GLM, so we're creating a binomial equation to model this data. So this is our like our output or y variable. These are our x's. So we're treating the zip code as a factor. You can also be really specific and say numeric, or you could say, I don't know, you can chain them too. You can do this, but yeah. Um, Same thing up there. I kind of went backwards, but and we can even compare it. So let's just say we want to compare this, and we can say tidy bad model, and then we can do this. What? Oh, there we go. So we can compare the models. You can see that clearly you're getting different values. So treating the data consistently is important. So, um, yeah. So for the odds ratios, I'll save, you guys can read that on your own, but I hope that this was helpful. If you have any questions, feel free to get in contact with me. My email I'll leave up here is going to be this. Happy to provide any like workshops specifically over what you're working on or office hours. But thank you guys so much for today.